Hello, this is Christina Pantamani, and I will be presenting the first of 3 artifacts for my final capstone project for CS 499. This project comes from CS 330, which was my computer graphics course, where I was able to render a 3D object, this burger, with a key light and a fill light, as well as enabling some mouse functions to be able to move around the object. So we started off with including some header files so that OpenGL could perform all the additional functions that we needed to. And we'll just general setup of the program. Here we're declaring variables for all of the items that we'll be using, shader programs, variables for the fill light, key light, and textures, variables for the mouse position, camera position, position of the burger, the key light, fill light, and the camera rotation. Here we've got OpenGL functions that we'll be using later on. And here there are some commented out pieces of code that we used earlier in the class to implement keyboard capabilities, and I'll be bringing that back to use the keyboard in order to move around the object instead of using mouse movements and clicks to move around the object. And there's quite a bit of commenting here, and that's actually helped me when going through the code to reread about what's going on with the code. Some things are not appropriate, like pyramid, which is the main thing that we worked on. So I'll be replacing a lot of these variable words with things that make sense for my burger project. So here's the vertex shader source code, which tells OpenGL where the vertices are. Fragment shader source code, which tells us the rasterization or the color of the pixels of what's in our window. And in the main function here, we've got this light calculations for our burger to include the ambient, diffuse, and specular lighting, and all the calculations for the fong. Similarly, we've got the same thing going on for the key lamp, fragment shader source code, and the fill lamp shader source code. Within main, we've got the main window being opened up here, which is important in order to be able to add in these other functions and render our graphics, as well as setting in these other functions here, which are written later on in this code to be able to perform mouse clicking and movement to move around the object. And like I said before, I'll be removing the mouse functionality and returning the keyboard functionality, and deleting what is unnecessary for the program that I've created, and then destroying the buffer objects once they're all used up. Here is a function to resize the window so that you're able to move the window larger and smaller, and it doesn't mess up the graphics too much. Here we're rendering the graphics with this render graphics function. Clearing the screen here, the buffer, as well as declaring these variables. This was a keyboard functionality that I'll be bringing back. Here we're transforming the burger, camera, setting the camera projection to perspective with a click of a button here. So there was one keyboard function. Here, for the burger, we're retrieving and passing this transform matrices to the shader program, and referencing the matrix uniform from the burger shader program to the burger color, light position, and camera position. And then passing that data into corresponding uniforms, generating or binding the texture, and then drawing out the burger shapes of the triangles within the burger. And then we'll deactivate it. Similarly to what just happened with the burger, we'll do with the lamp light, or fill light. No, this is the key light. So I'll definitely need to fix this documentation here to be more explicit about which lamp I'm talking about, because down here I have the fill light. And then rendering that shape of the fill light. Here is the uCreate shader program. And then later on, it would have, well, it's the burger, and then we got your key lamp, and then your fill lamp. And then this is the actual shape of the burger here in the vertices array. So the first three values are the vertex positions, and then the normal vector here and the texture coordinates. And I've got each shape sectioned out. The first part is cheese, something simple, flat and cube, then the top portion of the bun, going on down, and this was quite tedious to type in all of the vertex positions from Blender, clicking each one. So to enhance my project, I'll be exporting the data here into an OBJ file, and then loading all of this information into my program so that I won't have to type out all of that information. That was pretty tough. Here's a burger patty, cylinder made up of triangles. Bottom of the bun. That should be the last piece. All right, here we go. Generating buffer IDs for the burger, setting the attribute for the position data, setting the attribute pointer to the normal data, and then the texture data there, and then deactivating the vertex array object for the burger. And then we'll do the same thing for the key lamp, key light, as well as the fill light. This code here helps to load up the texture into the program to be used, and then these functions that were referenced earlier allowed me to use my mouse to move and allow the program to know where my mouse is and calculate what the view in the window should look like based off of the position of the mouse, as well as having it check for when the mouse was clicked and when the keyboard was pressed for perspective changes. This function was commented out. It was a function that we used earlier in the class to use the keyboard to navigate around the hamburger, which I'll be bringing back. And yeah, that's what I'll be doing to improve upon my burger, is bring in the data from a file instead of typing it out. That made the program very long, as you can see all the code that was written, as well as putting in multiple textures to make it look more like a burger. And yeah, adding these keyboard functions to walk around my burger. Be using the program I created for CS340, client and server development, which worked with MongoDB and REST APIs using Python. We started off with the bottle framework and importing some REST API calls, importing Mongo client to connect to the server, as well as importing items to work with the JSON, as well as pprint to display JSON nicely. We've got some setup here where we're connecting to the server, which is a local host, and establishing the connection to the database, market, and using the collection stocks. We've got my main methods here. We're finding a stock by its ticker symbol, requiring input from the user. All of my functions in main require input, and I'll need to make sure that the input from the client is safe. So I'll need to address the defensive programming and security aspect of that. Nonetheless, we've got input from the user, which will go into this query, find one, collection.find one, and if the ticker does not exist, it'll return an error, and if it does exist, it'll print out the stock information. Next is updating the volume, trading volume of the stock. Again, calling for the ticker symbol and the trading volume. If the trading volume is greater than 0, then you're good to go to set the new volume. However, if it's less than 0 or 0, the program will respond with trying again. Next is deleting the stock by the ticker. Pretty straightforward. Calling in the input, saving it into this variable here, deletion, and using collection.delete1 with this new JSON format to delete the document with that ticker symbol. Next, we're working with a 50-day simple moving average, where the user inputs a low value and a high value. And if those inputs are valid, if the low value is greater than 0 and the high value is less than this value, the program will continue and use this aggregation pipeline to find companies with the 50-day simple moving average between this range of being greater than or equal to the low value that was inputted and less than or equal to the high value that was inputted. If the range was not within 0 and 2.6, 714, then we'll print an error there. Next, we've got finding or querying for companies within an industry. So we've got industry input from the user, and the program will loop through each item that it finds within the collection saved in the variable stocks, and it'll count how many stocks there are as well as display the ticker symbol. The last main method is dealing with returning the total outstanding shares for a company or a group by industry within a sector. So user inputs a sector. We create another aggregation pipeline to find all companies that match that sector and then group it by its industry, then total the shares of each company within the industry and returning it as a list. Next, we've got API calls or functions. We've got a helper function here to insert a document, which will be used for the create route. So for the create stock route, the program reads in the body. If there's no data, it will return an error that no data was received. If there is data, but the ticker is not explicit and defined or given a value, then it'll return that a ticker was not specified and it won't create a new stock. But if the ticker is identified, then it will insert that document into the collection. Next is updating the stock, which is similar to the main method function. It requires JSON format of identifying the ticker symbol as well as the new trading volume. Again, if the trading volume is greater than 0, it'll set and update that trading volume and return the stock information with the new trading volume, and if not, then it'll return an error. Next is deleting the stock. Again, pretty straightforward. Getting an input from the user and putting it into this query here to remove. Next is getting all the stocks. Again, straightforward. The user doesn't even need to really put in anything here, just needs to call the stocks into the route. To get just a single stock, the user will need to supply a ticker symbol, and that ticker symbol is put in through this query to find one in the collection, and it'll return the stock information there. And lastly, we've got our main method here, where it's true, where the program will run until the user supplies 0 to quit the program. In this if-else block here, I could probably change that to a case block to make it look prettier instead of having, to write selection over and over again. And I've taken care of any values that are outside of this range with the selection is invalid. So to improve upon this, I'll need to dynamically pull in data, and I'm thinking about using the Yahoo Finance API, which was actually outdated and removed, I think, in 2017. But Rakuten Rapid API has offered a free tier to be able to use and call in data from Yahoo again. So I'll be using that to interface with their database so that I can get data in a more real-time sense. So I'll be connecting to that database with their API and pulling in their information to work with finding another way to present potential stocks for clients to purchase by using an algorithm to compare the 50-day simple moving average with the 100-day simple moving average. And if the 50-day simple moving average is less than the 100-day moving average, it shows a decreasing trend line and a likelihood for selling stocks if you own any. And in the reverse, if the 50-day moving average is greater than the 100-day moving average, then it's a buyer's market and it might be a good time to buy. So that's how I'll be enhancing this program, as well as reinforcing and bolstering up the security with protecting the program against inputs. final artifact, I'll be pulling my project from my Intro to SQL course that I took quite a few terms ago. It was DAD 220, I believe. We worked with a database called messaging that included these different tables here. They included various different people, Olympians, and was a text messaging database. And off to the left here, I had to complete several different tasks. The first one was inserting myself into the person table. And then the second task was altering the table, so adding in an additional column. I chose hair color, which was, in hindsight, doesn't make sense. And I don't know why I didn't realize it before, but I'll be adding in a different column. That makes more sense with a messaging application or database. The third task is updating myself, my row with the new column variable that I had set just prior to that. So I set my hair color to black. Fourth task was deleting a row from a table, so I deleted this person. And then now we altered the contact list table and added in another column called favorite. And then I updated those favorite columns where the contact ID was 1. And then here, task 7 was updating all the other IDs with no as favorite that did not equal, or the contact ID did not equal 1. Next, we did multiple inserts into a table. And then the next two tasks required creating a table. This is a completely new table where we included images at auto increment for its primary key for image ID and the name and location. The second table that was created was a hybrid between the message table and the image table, and it was called message image. And from here we can see that there are certain message IDs connected with an image ID, indicating that that message was sent with an image. Next task was inserting into the image table various records. Task 12, again inserting multiple records into the message image table. The 13th task here are querying for senders and receivers of message and including the message timestamp. Looks like we've got usage of aliases here. That way it saves space on having to repeatedly write a table name or something. And looks like we've got some joining of tables going on, and the condition is where the sender is 1. And I believe that is Michael Phelps there. Task 14 here is tracking the count of messages or amount of messages that a person was sending and grouped by that person's ID. And lastly, the last task was querying and joining for message ID, the message itself, a timestamp, image name, and a location of the image, and grouping it by the message ID. We can see here. So, to improve upon this, as I said earlier, including more aliases to kind of clean up some space, removing certain columns from the person table and adding in additional attributes. I had a tough time figuring out what I was going to do, but I did want to make it so that there was an administrative function here, and we need to add in some security. So I wanted to add in username and password protection in order to access this database. Additionally, MySQL often succumbs to buffer overflows as well as SQL injections, so I'll need to write my queries in such a way that a malicious person would not be able to hack into it. So I'll need to add in some ways to prevent that SQL injection to improve its security. And other ways, I'd like to use more advanced querying, potentially joining this table with another, or joining this database with another database that I thought was interesting. There's another database available to us called Flight Reservation. And there we go. And it's got some famous people and information about different flights. And so I thought, well, maybe there's a neat way to combine these two. I thought maybe if I can also create a trigger, say for example, the flight status ID changes from 1 to a different number, which indicates on time, delayed, or canceled, then it could update and send a message to somebody. So that would be pretty advanced, is joining across databases and including some triggering to perform a certain function when an event happens.